Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. This session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions so our presenter and moderators can answer. I'll now turn it over to our speakers for today, so let's welcome them here.
Awesome. Thank you so much for the introduction. Hello, everybody. Super excited to be back here. This is but one episode in our larger series that we're covering the full tech stack across Azure. We've had a couple episodes already on Migrate and Modernize, a couple on Unified Data Platform, and we're getting into more AI. But before we jump in, just want to give a deeper context into who our speakers are for today. For myself, my name is Aaron Stark. I lead all developer skilling and solution marketing go-to-market for all things AI apps and agents. And I'll pass it over to Spencer, who can give a little intro about himself as well.
Yeah, hi, I'm Spencer. Spencer Schneidenbach. I am a Microsoft MVP, and I'm the president and the CTO and owner of Averon Software, or Averon Labs now, which is a software and AI consultancy. So pleasure to be here.
And super excited to have you. Thank you so much for the time today, Spencer.
Absolutely.
I know this episode is going to be all about building AI agents, Microsoft Agent Framework, Postgres, API management. And before we kind of jump into the demos and some of the things that you brought for today, I would love to hear maybe some more foundational information. Like, what is an AI agent, and maybe what advantages does Microsoft Agent Framework offer compared to different approaches?
Well, you've come to the right place then. Yeah, I'm excited. I'm excited to kind of get into some fundamentals. We're going to be covering kind of a wide breadth today. A lot of fundamentals as it relates to agents and vector stores like Postgres, because I find that a lot of developers in the market are really struggling they want to see the code, but they also want to understand the core concepts. So I'm really hoping to bridge that gap today.
And for Azure databases, I know that we're going to have a focus on PostgreSQL. What are some of your over high level thoughts on PostgreSQL with AI? I know there's a different amount of databases that individuals can use. So why PostgreSQL for you?
So I'll be totally honest and say, Microsoft, love SQL Server, built a career on SQL Server, but Postgres is my heart and my soul. Specifically for AI products, the PGVector extension is really solid. It has been around for a while, so it's really quite a solid extension and has a lot of awesome support from Postgres. The PGVector extension is really the thing that enables us to really have a really solid embedding store alongside all of the indexing support, which is so critical for really fast retrieval, which we'll talk about. So I think I love Postgres because I think SQL Server just released their support for vectors in their in 2026. I think it was in preview before. I think it was in preview for that, but Postgres has had it for a while. So most of my new development is done on Postgres, and pretty much all of my AI database stuff is done on Postgres as well.
Got it. That's something I'm hearing a lot coming from the field, internal Microsoft, especially with other customers and partners that we work with. So nice to kind of see that there's consistency across the board. But the other thing I'm curious about is maybe API management. Could you talk to us a little bit more about how, from that foundational level, you see API management being relevant and how it kind of looks into the entire process?
Right. So if you're part of the Azure ecosystem and you want a cloud native kind of way of putting a front door, so to speak, not the Azure front door product, but the API management, like I better use a different term because front door is a product. If you want a layer that gives you kind of turnkey authentication, so rate limiting security, in front of, let's say you have a solution that's deployed to really Azure App Service or Kubernetes, Azure Kubernetes Service or Azure Container Service or really whatever. If you need something in front of that in order to, that kind of gives you that turnkey security and rate limiting, because as I'll talk about and I say all the time, LLMs, they're kind of expensive. You kind of don't want your consumers to be consuming all of your tokens because and I'm an Azure OpenAI person mainly, and customers don't really like to get surprise bills in Azure. I've found that's pretty much to be true. So if you need that way, that layer in front of your API to keep somebody from abusing it and triggering, and it just depends. And AI agents can take so many forms. You may not even deploy them in front of an API. They may just be part of a process that isn't triggered, that's triggered in some other way. But if you have an API that maybe triggers some kind of downstream agent process, you kind of need something like API management in front of it in order to, like I said, give you turnkey security. The rate limiting to me is the other really important piece as it relates to deploying agents that are callable via APIs. And that's really where API management can come in.
Couldn't have said it better myself, especially kind of as this episode is centered around building AI agents. We've had episodes that talk about building AI apps. The through line in between RAG, threading, actually having the API or the AI services. And then to your point, that piece on that turnkey security, obviously larger companies and different customers might use something different, but especially on a more entrepreneurial route, I think that's really key to highlight. Now, transitioning slightly, I know that you've brought a couple things for us to go through, so I'd love if we could put some things on the screen and maybe give you some couple minutes to chat through those.
Absolutely. Yeah. I've got a whole slide deck. I got a whole presentation. I got demos and everything, man. We're fully loaded. We're lots of notes today.
I'm this excited. I know that our viewers are probably even more excited.
Love it. Love it.
And then let's see, there's perfect.
And there it is. Okay. All right. Well, I am really excited to kind of go into this and interrupt me with questions. I see chat on screen. I know Aaron will keep me honest. Yeah. So I've got a somewhat brief 40 or so slides. And I'll have a link to the GitHub repo that has all of this stuff, all of my examples, all of my, and then my slides as well at the end. So I'll make sure to link that.
Thank you.
But I really wanted to kind of go through and kind of talk about what should we be expecting to learn? What should we be expecting to take away from this? So first, I want to kind of talk about, I mentioned earlier that lots of Azure developers are struggling to even understand kind of the basics. And it could be because could be a million reasons for that. But like, I really find it important to focus on the fundamentals. Now, I've talked about AI across several conferences in the last year. And most of the time, C# developers, .NET developers, Azure developers are just like, show me the code, show me the good stuff. I just want to call the thing. But we really need to it really is important to pause and say, hey, just take a step back a second. Let's talk about what is an AI agent. We got to even talk about like the definition, because it was kind of touch and go there for a while in terms of what the definition actually is. And how does Microsoft Agent Framework make it easy to build AI agents, which we will talk about for sure and provide plenty of code samples for. What does integration of AI agents and Postgres look like? Of course, Postgres, my database, heart and soul. That's why I took this job. I was like, yes, I want to talk about Postgres. I want to talk about Agent Framework. Those are things I love. And so what does that look like? What are the kind of the tools, the machinations? How does it actually look when the rubber meets the road? So what are the advantages of using Postgres? We kind of touched on that earlier, Aaron, when we were talking about PGVector being just such a solid, mature extension. So we'll dive into that a little bit more. And then we'll touch briefly on Azure API management as well, and talk about how it can play into an agent deployment. Although we kind of already talked about that a little bit, kind of spoiled my whole content. That's all good though. We're going to talk about it, give you an opportunity to ask questions. And I wanted to tell a little bit about me. So as I mentioned, I was a Microsoft MVP for 10 years, mostly in developer technologies. My background is in .NET. And as of this year, I got the second credential because I've been doing lots of AI talks. Now I am an AI and developer technologies MVP, which I was really proud of. And then I am the president, CTO, and AI architect at Averon Labs. It's a small boutique company based in the United States. We make software, especially web-based .NET, React, Node, on AWS and Azure, mainly Azure. And as well, now we're AI architects, so we're executing and building on AI projects. So I want to emphasize, these are experiences that I've drawn. I'm showing you lots of basics, lots of code samples, but this is all real stuff. This is all pulled from my real experience with AI systems powered by Agent Framework and Postgres. Full disclosure, Agent Framework is still in preview. That's, I think, is a really important thing to say. The APIs are still kind of in flux. I have seen when I've fired up example projects where I'm like, oh, yep, they maybe changed a little API again. So lots of my experience is, again, focused on these fundamentals, these AI primitives for a reason, because I believe, I know Agent Framework is the piece of the investment point that Microsoft is making. Previously, it was semantic kernel. I'm still using semantic kernel in production because it's a really solid framework. So if you needed to start today, semantic kernel is also a great option, but Agent Framework is showing lots of promise, but it is still in preview. So all these APIs are in preview. And it's important to note, probably, I don't know, Aaron, maybe 2-3 months when we do this talk again, we'll be able to say, yes, it's version 1.0. We can do it again.
In a perfect world, yes, Spencer.
Okay, so I want to talk about the definition of an agent. So about a year ago, when agentic programming and agentic development from an AI perspective was going on, a lot of people were talking about what even is an AI agent, and I think that there was a lot of confusion around the term, and I personally kind of really settled on basically a very I took it to a primitive point of view, which is that it's really just an LLM call that can do something. It can perform a task. It can do some kind of categorization. It usually means on the other end of that you've performed some kind of mutation or made some kind of thing that made it do some kind of thing that is meaningful to a business, or whatever the thing that it is you're trying to do. And I think that this was really kind of I would say this is kind of an awakening moment for me, because there's a lot of the term agentic and agent really caused a lot of confusion in the market and for developers in what was already like a confusing and rapidly changing landscape. But a lot of people would look at me and say, well, that's great, but I can use a chat completions API and make an LLM call and then update a row in a database. Is that an AI agent? Well, maybe. I think at its most basic term, that's what an agent is really just a thing, a thing that is sent to do a specific task. And so I think that it's important that while my definition of an AI agent is one thing, and I think it's still correct, lots of people would say an AI agent is really when an AI process is able to act independently of its controlling user or owner, entity, business, whatever the case may be. So it usually has a way to act with some kind of independence. And they typically vary on a system prompt. If you're not familiar with that, a system prompt is basically just a way to provide additional instructions like, hey, your name is Barry, or, this is what you're allowed to talk about. This is what you're not allowed to talk about. The instructions that you can give an LLM call ahead of actually doing some kind of work. So that's what a system prompt is. It typically varies on the model type. So a agent isn't necessarily, you could have an agentic system. Microsoft Agent Framework would support this out of the box. You could have an agentic system that allows you to, one agent we found, through our eval process, our testing process, is really good on Sonnet. So Sonnet 4.5. So we're going to invoke, this agent is specifically going to work under Sonnet 4.5, but it's going to be orchestrated by another agent that is GPT-5 on OpenAI or Azure OpenAI. So whatever the case may be, right? An agentic system doesn't have to rely solely on one AI model. It's going to vary on whatever the task is, whatever the task that's most appropriate. And my rule is I tend to use smaller models as much as possible. I love GPT-5 Mini. I love Nano. I love 4.1 Mini and 4.1 Mini. Those are the models that I really like, because I like to try to really use the smallest model to perform the task at hand, as small a model as I can get away with. And that's mainly from a cost savings perspective. Also, I like doing less with more, or more with less. That's just kind of philosophy of mine. And then it varies. The agents typically vary on tools, aka little slices of functionality that an LLM have in order to perform some kind of task. And because, hey, I'm a .NET developer, I'm going to show you lots of tools that are defined as C# functions. Yes, LLMs that are invoking your own code. It's really a powerful concept, and it kind of twists developers up a little bit. They're like, wait, is that a good thing? Like, what if the agent goes out of control and starts invoking and reflecting on my DLLs and sending all of our code up to Microsoft so that Satya can, rework my company or whatever the case may be? Not the case, right? We're going to be just defining a small set of functionality that the agent will be exposed to in order to perform the task that we have. And here's pretty much an example of the smallest example that I can give you of an AI agent built in Agent Framework. So if you have a client and you can invoke a client, create a client in just a few lines of code, you go response client, and then you can call create AI agent once you've installed the requisite NuGet packages, which again, preview, you have to use the pre-release versions because there's no solid API at this point. And then it's very simple. We've given it basically a set of instructions, a system prompt, as it were, and a set of tools that the agent can invoke in order to do the work that it needs to do. So, fun fact, spicy opinion. I love Codex. I love Claude Code. GitHub Copilot is pretty okay. I love Cursor. I like all of these AI tools, but really, they all have one thing in common, which is that they're just LLMs that have access to a file system, right? And have specific instructions and specific tuning and specific training on how that works. So you could go in and using Agent Framework, you could go in and theoretically make your own coding agent and use Agent Framework as your base. You can make your own CLI tool and use Agent Framework as your base for actually executing those tools, depending on what you wanted the workflow to be. So in this case, we've just basically given it you're a code review agent for reviewing code. You can list files, you can read files, and you can run bash commands. The run bash commands better, of course, be coupled with lots and lots of safety. You just don't want LLMs to just willy-nilly invoke bash commands, but this at its most basic is kind of what an AI agent, that's how you define one in Agent Framework. It's very simple. Got its own prompt and its own tools.
I love that you're able to kind of show basically, like, I think sometimes there's a misconception that agents have to be overtly complex or over-engineered at times, when obviously that does exist. There's use cases where that fits, but it could be as simple as exactly what you're showing here. Yeah, and agentic programming and agentic development can take lots of different forms. My favorite way to do agentic development doesn't use Microsoft's Agent Framework at all. It's running Claude Code in a loop and having it do stuff. And basically, like, I usually have one of my employees has it right now, but I usually hush the room and I say, I want to introduce you to Claude. And I bought a MacBook Air specifically that all it does is sit over here at my desk and run Claude overnight. That's my favorite AI agent, right? It just does stuff, but I don't want it to have access to my work computer. That's why I have it run in a sandbox, and I was just easier to do it that way than to try to set up a bunch of virtual machines on my Mac. But anyways, agentic programming can take lots of forms, but in its most basic term, it really isn't difficult to define a basic agent inside of Agent Framework, which kind of brings me to my demo of just kind of showing you a basic agent. So let me switch over here to my IDE choice. Here we go. JetBrains Writer. Oh, I just tried to maximize it and went to the other place. It went to the other side. There we go. Let me close all these. And I'm going to have all this code available in the GitHub link near the end. I will definitely be able to drop that. Perfect.
Drop that in. So I've got a really simple one. First of all, of course, we got to do some house cleaning, got to do some housekeeping, right? You got to define the deployment that we're using. So just to be clear, I am using Azure OpenAI. Let me pull it up here. I got my Azure OpenAI deployment, couple of clicks. I'm not here to sell you Azure necessarily. I love Azure, just to be clear, but a couple of clicks and you got yourself an Azure OpenAI deployment. And I believe most of the time, I think that Microsoft is slowly pushing you, like, actually, you shouldn't use the OpenAI deployment. You should actually use the AI Foundry deployment, which I'm all for. Yes. Bad habits. What can you say? It's a little habit of mine.
Slowly but surely.
Yes, exactly. But basically, I was able to come in, create this resource just specifically for this talk, and then come in and show text embedding 3 small, and then deploy a couple of AI models using my Azure subscription, which is nice. I mean, I will say it is really nice to come in and just create this deployment and not have to pre-charge and use it. You know, it just comes with my Azure bill, which is nice. And then I've got GPT-4.1 and text embedding 3 small, which we'll get to text embedding 3 small. We're going to use GPT-4.1 though, which I think is still even if you're like, I still have people running on GPT-4.1 because you can't just flip an AI to 5 and expect, oh, it's all going to magically work just fine. Let me tell you from experience, maybe not a good idea. So we're just going to stick with 4.1 for now, which is still an amazing model. It really is a good model. And we're going to define our endpoint, pull it from the environment variable. So that way you all in the audience don't blow up my my OpenAI API bill. I got my endpoint, I got my API key. And then what I've done is kind of set up kind of a little bit of a contrived kind of, you know, thing. And it's basically like, let's pretend that this is a order database, right? That has some order numbers in it. And what I've done is I've defined a series of tools to say, basically, how can I look into this database in order to answer a specific question? So here's a tool that the LLM can choose to invoke, which is get order status. And basically it takes in an order ID. And then what it does is it returns the order ID back to the LLM for some processing. I do want to point a couple of things out. If you're not familiar with tool calls, you note that the get order status returns a string. You can return more complex objects, but most of the time in my tool calls, when I'm speaking to LLMs, I'm usually returning string, just because that's how an LLM is pretty much, you know, going to interact with you. It's just basic English, and the string might contain JSON. I tend to like to speak to LLMs in XML or Markdown. I don't like to speak to them in JSON as much. LLMs and XML and Markdown are great formats, and most of the major model providers, those are the ones that they recommend you use.
Especially because it could get a little bit more complicated, I think, with the JSON route. So yeah, different options.
Yeah, I mean, it really is kind of like, this is readable by a human, and if it's readable by a human, the more readable by a human it is, the more an LLM is going to be successful in using it.
And then Spencer, before we move on, are we able to zoom in a little bit? I see here in chat, I think we have a question just about,
yes,
whatever makes the most sense.
Keeps learning, Yogesh, definitely. You are seen, you are heard, sir or madam. Review for you. Okay.
Thank you.
Okay, so we got this. Look up the order by its order ID, list all orders for the customer, and you're probably not going to pass in the customer's name, Spencer. I believe that's what it is. Yeah, Spencer, Alex, and that's my son's name. How funny. I didn't generate this. Claude did. Maybe I should be a little creeped out by that. Claude, you maybe know a little bit more about you than I know. But anyways. We got our customer's name. We're just passing in Spencer, you know, whatever the first name is. You know, obviously a very kind of overly simplistic system, but we're focusing on the tools part. Well, that's a really important part. Current date and time. This is set in a separate tool. Most of the time, I usually put that in the system prompt because it's important to ground a model in the current date and time. But that works too. And then basically we've defined ourselves an AI agent. So first of all, we've defined using the azure.ai.openai package. From this package, we've imported our Azure OpenAI client. We've given it our endpoint. We've given it our API key credential. And then from there, we have installed, I'll just show you you know what? I'll show you the packages here. This is where I think you'll be able to see it a little better. You see, we have Azure AI OpenAI, and then we also have Microsoft.agents.ai, and then the OpenAI integration with that, in case you're using OpenAI directly. And then, of course, Microsoft Extensions AI, which was a very welcome change by the .NET team to actually give us some foundational primitives in .NET for really using and consuming AI constructs, as it were. So this is from that. You get, we've got our chat client, get our chat client here from our deployment. And then from there, we create our AI agent and we give it some instructions. Again, that's the system prompt, and give it a name optionally if you want. And then we're able to give it a series of tools. So get order status, get custom orders, get current date time. And then down here, we've basically just started a new thread. So get new thread is basically an invocation that says, hey, I need something that will track the chat history. So before, a lot of times in other frameworks and in OpenAI's or in the in the OpenAI's framework or at Microsoft.extensions.ai. Lots of times, in many frameworks, you have to manage your own chat history, which I'd argue is not a bad thing. But if you wanted something a little more turnkey, Microsoft Agent Framework kind of has that out of the box, where basically they have this thread abstraction that will basically read and write to the thread as is needed automatically. And there's one basically the store for this right now is in memory. So this will disappear as soon as we shut it off. We will show the Postgres integrated one. It's going to be great. But I'm going to go ahead and run this. So basically, this is going to be a series of 4 LLM invocations to say, hi, what's the status of this order? What other orders do I have? My name is Spencer. When will my magic keyboard arrive? And what day is today? So I'm going to go here. I'm going to hit play. Oops, the wrong agent. That's the next demo. How about that? Let's try this. How about you try this one? Here we go. Okay. Hi, what's the status of order ORD001? And behind the scenes, Agent Framework has used our Azure OpenAI deployment and has invoked this tool to say order ORD001 for the MacBook Pro 14-inch. Again, Claude really showing how creepy it is because that's actually the computer that I'm running this on. And then giving me the date time. Here's where the order was, and your order was placed on December 5th. And by the way, your order was shipped. So through all that, through defining our agent here, right? And then just asking it a question, the LLM behind the scenes has decided, yes, the get order status for this customer order is the thing appropriate to handle that request. So it went ahead and invoked that. Invoked that function that we've defined right here. Pretty cool.
That's perfect.
You press any key. What other orders do I have? My name is Spencer. Well, of course, now it's able to look in. And of course, the LLM has no knowledge of this. The only way that it can do that, no knowledge of this ahead of time. The only way that GPT-4.1 knows that we have these orders is by using these tool calls. And it's correctly identified, the customer Spencer has these specific orders in flight. And if I said my name is Alex, it would then look up order 003. And then when will my magic keyboard arrive? This is where it's looking up and saying, oh, magic keyboard, this is an order that he placed. And the exact delivery date that isn't available yet since it's being prepared for shipment, which is correct. Once status change to shipped, I'll be able to provide a more specific arrival estimate, blah, blah, blah. And then, of course, what day is it today? It's going to invoke today is just Tuesday, December 9th, 2025, because an LLM, including ones that you call programmatically via an API, do not intrinsically know the current date. It's usually, it's almost always very helpful to I usually stick the current date time in the system instructions. But anyways, very simple, not a lot of code. What do you think, Aaron? You think that's, what do you think about this?
I think that's, especially because there's just so many different small helpful pieces in here. Like I mentioned earlier, the use cases that exist for us leveraging agents could be from very small use cases to larger. So I think this is great when we're talking about the foundations of really everything. This is where you could start at, and obviously you could build this up. Like Spencer mentioned, he literally runs his own company, leveraging a lot of this stuff. In my own role at Microsoft internally, we use this day to day. So I just love that we're being able to put it in kind of one package and hopefully democratize a lot of this information a little bit better. Yes. I do have a question from the chat as well.
Yeah, I see a lot of good questions coming in.
Perfect. From Ashrit, I'm not pronouncing this right, but ASHRITHV 9370 has a good question about security. How does security play here? And basically to avoid showing wrong information or wrong orders specific to this use case.
Right. So in this example, I'm just invoking and asking a question, and the LLM, of course, the LLM has no knowledge of who Spencer is. And the way that it's designed, you could see orders for any customer in this, very simple contrived example. And really, I think the big secret is that good AI development is still 90% good software engineering with AI sprinkled in. That's the thing that the AI bros and everybody aren't telling you. Is that LLMs are not the magic behind the scenes. I could go into this is a really good question, and I could go into this all day, but I'll give you an example. If you're using ASP.NET Core as your foundation, let's say that you're using ASP.NET Core, and then buttoning agents on top of that, you have perfectly good abstractions already to identify the user. If the request is coming in via HTTP, then you've already got on your request context, you already know who the user is. So you can then appropriately give it tools that are already pre-filtered to only show orders that are relevant to that user, or only show questions that are relevant to that user. So it's really just reusing existing constructs and then giving tools to the LLM that only that user can invoke, or see. So they can't see filters. So that's not possible in the AI systems that I build. And I see people try this all the time. I love it. I love it. Keep it coming. If you're my customer, keep it coming. Okay. I'm telling you, you come in and you say, well, actually, I'm not Spencer. I'm Aaron. I'm actually, impersonating Aaron because I want to see what he ordered on Amazon or whatever the case may be. It's literally impossible for an LLM to finagle its way in because of the way that my tool structures are designed. They already know that the user's me. They cannot possibly override what already exists. That would be unless they were able to override their cookie or their API key, which is borderline impossible for most people.
Yep. Thank you for that, especially, and just to kind of close the loop there. Obviously, there's a larger conversation, as Spencer mentioned, I talk about it all day, around security, what this looks like scaled up, but within the confines of this example and kind of he just explained, that shouldn't be those issues that we should see. I see another question here from Martin Saucier, 1962. Can you see and or trace how the reasoning engine, Microsoft Agent Framework, decides which tool to use versus another tool based on the prompt?
That is an excellent question. And the answer is it's not Microsoft Agent Framework making the decision. It's actually the LLM. So in this case, GPT-4.1 is deciding to invoke that. All we're doing is using Microsoft Agent Framework to provide a really convenient development model for us to define our functions and then invoke that LLM. And then invoke that LLM and say, here's the tools that you have available. The answer to your question is that this is a hard problem too. And it really comes down to really good testing, because I have I have a system that has 50, 60 tools available to it. Now, you send all 60 tools to an LLM, it's going to fail. It's just not going to do a good job, and you're going to burn a lot of tokens. So what we do is we have a suite of about 500 tests, and it costs about $20 every time we run this test suite that invokes the LLM and says, are you calling the right tool? So that is a massive question, way outside the scope of this talk, I'm afraid to say. But I would say if you're building AI production systems, please invest in evals, invest in testing. It's the most important part of the whole. It's the most important part of the whole thing. But really, the short answer to your question is really up to the LLM, not Agent Framework.
And Martin, just to add to that, if there are additional questions just from the chat or other viewers, again, this is but one episode. We're more than happy to take in any other interests, and maybe there's future episodes where we can dive into this a little bit deeper. Sure. Going to Ankita Lambada 8249, I see that you had a question here about understanding the prompt. I'm not sure if Spencer, you have any thoughts on that, but I will say that we do have a plethora of resources. Spencer is also going to provide the link to his GitHub repo. So at the end of our live show today, you'll have an opportunity to kind of be a little bit more interactive. But Spencer, I'm not sure if there's anything else you wanted to add to that one specifically.
Yeah, so provide an understanding the prompt maybe after session. The bottom line I would say is that good LLM systems start with good prompting. Good AI systems start with good prompting. Anthropic probably has the best resources, in my opinion, for their docs are very applicable to, like, their good prompting docs are very applicable to even OpenAI. Or Grok or whatever model that you're using. Certainly they're very good for Anthropic's models, but they provide the best prompting guidance. OpenAI releases prompt guides all the time. So the bottom line is that really you have to start with a good foundation, typically by reading what the big model providers like Anthropic and OpenAI are saying about how do you write good prompts, and then back that up when you're building production systems by writing tests for every single change that you make to your system.
Yep. And then in our not last question, but another question that we have here is from Gripillai. I said that wrong. Giripillai. In the example shown from the chat interface, the question is sent to the LLM, and then it comes back with needing a tool call.
Yep.
The question is, does this not introduce latency? Instead, what if you ran the LLM locally?
Yeah, so I think that this goes to what a good question developers often ask: how do we make it as fast as possible? But really, it's really about how you make it fast enough for the business case that you're trying to cover, for the use case that you're trying to cover.
Great
So I'm going to
point.
hit play, and I'm going to say, "Hi, what's the status of order?" That took about a second to return. So like that, in that time that I hit that play button before I even finished my sentence, it had sent this to the LLM. The LLM had responded and then already invoked the LLM had responded. And by the way, there's multiple hops that are happening. So we asked our question. The LLM decided, hey, we need to invoke this tool to get more information. It invoked the tool. That tool call was sent back to OpenAI. And then it further responded with its, primary response. And that happened within the space of a second, maybe even a little less than. So I believe that when you're talking about this is probably fast enough. You can run local LLMs. All of my customers and I pretty much use the big guys, Anthropic, OpenAI, Azure OpenAI is pretty much where most of my production deployment happens. I'm not saying that to sell you more Azure. I'm just saying it is truth. Okay. I use Azure. That's why I took this to a speaking role. So I would say that in most cases, there's a difference between fast and fast enough. And I think for my customers, for the systems that I'm building, this is way fast enough. Local models is another big subject we could dive all day into, but I mostly stick with the big guys and I've been very happy.
Couldn't have said it better myself. Just to add on to that, especially looking at the other customers that we work with, both large and small, digital native up to enterprise, that 80-20 rule that I think is applicable across all different things in life, I think really leads in lands here, specifically around fast enough versus being the fastest. There's the API management, which we'll get into later to kind of understand. I think the costs associated with a lot of that is the big question, especially as models continue to get smarter and cheaper, but fast enough, because a lot of these models are state of the art and able to really push things to the limits in ways they haven't been.
100%.
So I'll pause there on questions just so I'll let Spencer kind of get into the next portion, and then we'll obviously open it up to some more questions once he gets to the next demo.
Yeah, I said 30 or 40 slides, Aaron. There's actually 50. So we're gonna try to keep the next part brief, because I definitely want to talk about the Postgres side, which is also really important. I want to go back to that definition of what an AI agent is. So I defined a very simple agent that can kind of stand alone, and really it's just an agent just wrapping chat completions with some tools. And Agent Framework just provided a really nice development model for that. But a lot of people, and I would tend to agree with this in terms of the colloquial definition of what an agent is. An agent needs some degree of interaction with other agents to truly be an agentic system. And so they need to be able to at least decide, in order for it to be truly agentic, right? If the LLM is truly making a decision, it needs to be able to decide if another agent should be used to do a job. So a great example of this is Claude Code. You can actually, specifically, if you're using Claude Code, you can actually say, hey, I have a special task that I need you to do. Can you spin up a sub agent to actually perform that task and then return that information back? And that's really useful because agents typically have their own memory and their own context window. So if you've ever gone to ChatGPT or a similar chat product, and you had a chat thread and it was getting a little long in the tooth, the idiomatic expression in America, meaning it's getting quite long, quite big. And you're like, you know what? I'm just getting some funky answers. I'm just going to copy and paste all the relevant stuff into a new window and then see if the LLM does better. And most of the time it's going to do better, because that context window, you've taken that number of things that the LLM has to analyze and you've shrunk it entirely. So agents in this case have their own context window, and a sub-agent in the Claude Code sense would have its own context window as well. And that's very important, because that's an important concept, because that means that the agent can kind of do its own work without having to worry about all these other tokens and all these other words that you've sent into it. But they could still share some state or context. They could use tools. They could use shared tools to invoke some kind of shared memory, like a file system, a database, a shared architecture file, or a shared database that each agent can search. So let me talk to you a little bit about what in the wild you will see. And we're going to have a very brief demonstration of a very simple sequential agent, plus a little bit of observability. But I do want to talk a little bit about the types of agents that you're likely to build or encounter in the wild. So manager agent, the manager pattern is an agentic, where basically an agent has the ability to delegate tasks out to sub agents as it sees fit. A triage agent is a form of a manager agent that is able to then turn around and say, oh, based on your incoming request, in this case, where is my order? The triage agent is able to come in and say, oh, this is the appropriate agent to handle your task. And an LLM is probably going to say, oh, the order sub agent is the one to handle this task. And you're probably wondering, why not just have the one agent handle all the things? Well, like when you give it more context, an LLM is just going to be more successful the less you give it. When it comes to LLMs, less is more 100% of the time. So I typically will create sub agents that have a smaller tool set. Remember, tools, or I should say, tools are tokens too. Okay, tools are part of an LLM's context window, even if that's not immediately apparent. But you consume tokens by sending tools. And the more tools you send it, the more your bill goes up, the more your manager comes and yells at you because your Azure subscription just blew up and now his boss is yelling at him. It's a lot easier and it's a lot more successful if you can define a sub agent that can handle a specific slice of tasks. And that's what the triage agent is really able to do. The aggregation pattern basically might look a system like this. Basically we're able to delegate specialized tasks off to sub agents, then merge them at the end. So in this case, where we have customer service calls where there were payment issues, a manager would come in and say, look for the calls, look for macro trends, look for agent scores if they're being evaluated. And then an aggregation agent at the very end actually then sums up all that data and then responds. Now you talk about latency. Is this going to be slow? Probably. It's probably going to take a couple minutes to return, but this is kind of like the deep research tool in OpenAI. This is probably going to yield back a lot better picture. And do you need this level of complexity? Maybe, but now you at least know about it. So you can talk about it and say, oh, you're the AI architect at your company. So now you're able to maybe implement something like this. So just a few agentic patterns to kind of just mull over, think about as you get into your agentic development world. And then, of course, we have to talk about guardrails because AI agents cannot and should not be, depending on the task. Remember, I have an entire MacBook that does not have access to anything of my personal data. It doesn't have access to my iCloud. It doesn't have access to my GitHub. It basically doesn't have access to anything except for Claude and a file system. And I do that very deliberately because I don't want the LLM to go off the rail and, say, I'm running this overnight with all guardrails turned off. Why would I want it to give it access to my system? That's not a good idea. So you want guardrails in place to make sure that an agent isn't going off the rails. And it's mainly relevant in systems where agents are acting with autonomy, especially if they're acting with autonomy with tasks that require like a good amount of security. So probably the most common guardrail is human in the loop. It could be a content length guardrail to say, hey, this is getting too long. We need to summarize this conversation before we continue. It could be content safety, which lots of LLM providers have safety guardrails, including Azure OpenAI, which usually I have to turn those all the way down because sometimes they can be a little sensitive, but content safety guardrail, they're there if you need it, depending on, but a lot of the LLM providers are not allowing you to do illicit or immoral things. And then relevance, because if the agent is drifting and another agent has detected that drift, for instance, it could be an agent that is a guardrail for a different agent. So, and then we do have abstractions for all of these. Can we go over all those abstractions? No, but we can show you a really basic one. So we're going to just show you a series of agents plus a little bit of observability. And we're going to do our best. I'm going to play this and then I'm going to show you, and I'm just basically going to sell you on the development model and talk a little bit about observability as well. But we're going to breeze through this one because, hey man, this has been fun already, but boy, we are getting low on time. We got to talk about Postgres. We got to talk about Postgres.
We got to get to the Postgres.
Yes. So I'm using Jaeger for my trace visualizer, using test containers. If you're not a user of test containers, you absolutely should be. It is my favorite way to define and spin up containers that are temporary. They basically allow you to create containers in the scope of this application as it's running, and then it gets dropped after unless you define specifically that you don't want it dropped. So, which is pretty amazing. But so important to say, Agent Framework supports OpenTelemetry out of the box, as it should. So we've basically defined our tracer provider here, just a bunch of boilerplate for actually writing to the tracer and giving it the proper context. But you see here that we are indeed using OpenTelemetry as in our chat client. You'll notice here that this one looks a little funky. We've got our Azure client as before. We've got our chat client, but we've called it with this as I chat client. And this I as chat client basically converts it to an I chat client, which is Microsoft Extensions.ai's abstraction for chat clients. And then we're able to call as builder, again, a little funky. We call as I chat client as builder, but it basically gives you a way to layer in middleware. And in this case, the middleware that we are adding is OpenTelemetry, which is really important. Note that I have enable sensitive data true. You'll see why here in a second. No, it's not going to show you my API keys, but it's going to show you a little bit of extra information. And so what we have is 3 agents. You're a content drafter, write a brief first draft based on the user's topic. You are a content reviewer, review the previous draft and provide specific feedback. And then you're a content polisher, take the original draft and the reviewer's feedback, then produce a final polished version. And so we're going to build a very simple sequential workflow where we've defined these 3 agents. And what it's going to do is we're going to invoke one agent. We're basically going to create a workflow and then invoke that agent with a specific prompt. And then, and then each of these agents are going to be invoked in turn. So in this case, our thing is write a tagline for a sustainable coffee company. Very simple. We're going to turn on the in-process execution workflow. We're going to define our work. We've defined our workflow up here using our build sequential, which again, part of agent framework. Very nice. And then what we're going to do is we're basically going to start the workflow. And it's very simple. We define that we want our agent run to be streaming because we want to stream back the data. And then we send it a turn token, basically tells it you can go ahead and start. And then we're going to go and watch the stream and then basically watch it actually go through all of the event. So this is a lot of code to throw at you. I suggest at the end, definitely download the code repo and mess with it for yourself. Also, Agent Framework itself has a lot of great examples inside of its own repo. So I'm going to go ahead and run it, and I'm going to show you what it does. And it's basically going through. It says the original draft, if I can find it, was savor the taste, sustain the future. And then it's given you some feedback. Brew better, savor the taste, sustain the future. Brew better is catchy, but it might be clear to reference coffee directly. Suggested improvement, blah, blah, blah. And then it passes it on to the final agent, the brewing a greener tomorrow, 1 cup at a time. Is it a great tagline? I don't know. That's really, there's no accounting for taste. But I do want to show you Jaeger because when we're talking about agentic systems, it's really important that you be able to observe what's going on. Look at that cute little gopher. I think that's a gopher. Look at the we need to see what's going on. All right. We need to investigate. So in this case, we have ourselves our call to our agents, and you can go here and see all of the actions that the agents took. So it took about 2.5 seconds. And in here, you're able to dig in. And because we have enable sensitive data turned on, we can actually see the messages. Mm-hmm. And I think that this is one thing that I think lots of framework providers do. And I think Microsoft was definitely been guilty of this sometimes. They try to take away and abstract too much from the developer. And I fight that. And I say, no, we have to understand the primitives. So when you're doing that, what you're basically able to see when you do something like this is you're basically able to see these are the exact LLM calls that are being made to the LLM. So I could turn these around, put these in Chat Completions API, use Postman or my favorite or curl, and basically replicate this, basically redo it such that I'm able to actually see what's going on under the hood. And I think that the Agent Framework's observability integration is really important for being able to do that. And you could use, we're Azure people. We gotta say an Azure product, don't we? Is this the part? Satya just, yeah. So Application Insights, Azure Application Insights is a preferred, is a tool. There's plenty of open source ones. Jaeger, obviously I pulled up. Grafana is another. You can pull whatever one's appropriate for you. But Azure, Application Insights is a good tool, and we do use it a lot. I've used Datadog. I've used a bunch of them. But you're able to basically, because it's OpenTelemetry, see all these traces, come in, go down, and you can see all the invocations. You can see all of the different things. So in the second agent, the content reviewer was told, write a tagline. Here's the tagline that we sent. And then the reviewer came back with its feedback and said, here's what we should do, or here's what we think we should do. And basically it's just a series of LLM calls. So this charts it out for you. So observability, that's my pitch, is make sure that I don't care what you use, just make sure observability is part of your pipeline.
Perfect. And now, Spencer, I do just want to flag within our last 10 minutes, hopefully we can get to the bread and the butter, all of the
yes.
things Postgres.
Let's talk about Postgres, because I know we've gone through a lot. We've had a lot of fun. Aaron, we got to do another one of these. Got to do this again.
That's what I'm saying.
Okay. So this is Postgres. I mentioned earlier, I am a stand for Postgres. It can do no wrong. I pulled this off of some random Hacker News comment, and I was just like, you know what? This is my phrase. This is my go-to. So we're going to talk about two major things as it relates to Postgres. We're going to talk about storing chat threads, which is arguably a little boring. And then we're going to get to the good stuff, which is doing RAG using Similarity search. So it's important to say that if you're doing any work with an LLM-based system, especially if it's a chat system where your customers are using it and you want to be able to see what they're saying, you want to be able to store the messages. And so where do you store them? That is the question that we're going to answer, right? So this is a link you can follow inside of the GitHub. If you go to the repo and look at the slides, follow the link, you can see in the responses API, OpenAI can store these threads for you on their server. I typically don't use this, and I don't suggest you use it. Retention policies, they say that they retain them forever. But who knows if that will actually be the case. You can't query across message threads, so you can't do your own search across them. Let's say that you want to find create similarity searches across multiple message threads, and then see like what users are asking about. You can't do that easily. You can't later summarize and continue without starting a new thread. Summarizing and continue, of course, is being a really important piece of building AI systems. So it's super easy to roll your own. So I'm going to show you a really brief demo of thread storage. And basically, I'm just going to go through the abstractions, and then I'm going to show it to you. And then we're going to get into similarity search, because that's really where it gets important. So I'm going to go here, and I'm going to show you that we've defined this Postgres chat message store. So we've inherited from this chat message store, which is an agent framework abstraction for basically saying, here's how I want to read and write messages. And you can do this. You don't have to use, you can use my code if you want. You don't have to use this. You can build your own. It really might be dependent on the system that you're building. But essentially, what we're doing here is when we define our AI agent, when we go create AI agent, we're giving it a copy of this Postgres chat message store. So it's not using the one that's in memory. It's actually using the one that is inside of the database. So I'm going to hit play. I'm going to say, it's great to meet you. That's awesome. You're passionate about building AI applications. What's my name? My name is Spencer. It's to show that we're able to use across a thread, be able to ask and answer multiple questions. That's what the LLM can do. And then we've stored that inside of Postgres. As I promised you, here's Postgres. It's Azure Postgres Flexible Server, which is a server that I use in production. I do like Postgres Flexible. So just saying, there's my other Azure pitch. I do like it though. It is a really good service, and Postgres is my favorite. So, but you can see that we have it inside of my Postgres database. We're able to see it and store the chat messages. And you're like, okay, Spencer, but I could do that anyways. I could do that myself. Let's talk about the really good stuff, which is similarity searches. I only got a little time left, but I do want to talk about a little bit of basics, because I think this is really important. Yes.
We can go over like a couple minutes if you have. I'm not sure if you have a hard stop, but
I don't have a hard stop. No, I just want to be respectful of the time. I could be talky. I'm not gonna lie.
No,
if we can go over a couple minutes, that's brilliant. I'm happy to do that.
Yep. Want to give you some more time to go through this.
Cool. So let's talk about what an embedding is first. An embedding is a numeric representation of the semantic meaning, content, and contents of a given medium. And in this case, we're really focusing on text, because text is the really most important one to start with understanding, because that's what we're talking to with most LLMs. And it's basically as simple as you see on the screen. We have a snippet of text, and an embedding is basically an array of floating point numbers that represent the contents of that text. So another thing that we will, an embedding model is a thing that converts a piece of text into an embedding. In this case, we're using OpenAI's text embedding 3 small, which is a really good one. And it's important to note that these embeddings generated from one model can't be used in another. So you can't turn around and use this in a Mistral embedding model or anything like that. You're going to be using text embedding 3 small with other text embedding 3 small embeddings. And it's important to note that embeddings, another property they have is dimensions. The higher the dimensions, the more semantic information is captured. So bigger embedding models are more expensive, but they're more accurate. Text embedding 3 large is about 10 times more expensive, but you get a lot more nuance encoded inside of the dimensions. Do you need that extra nuance? Well, that's really a cost benefit problem that you as a developer get to solve with your tests, of course, as I already mentioned. But the important takeaway is that a smaller embedding model is probably going to be limited to a series of dimensions. Larger embedding models will have more. So how these get stored is inside of a vector database. These are vectors. These are arrays of floating point numbers. And Postgres is our embedding store, our vector store of choice in this case. And it's the one that I use in pretty much all of the AI projects that I use. There's lots of off-the-shelf products that are good vector databases, but I found that I can use Postgres for most of what I'm able to do, and it's worked really well for me. So Postgres, the really magic thing about Postgres is it supports this thing called extensions, which are custom plugins for the database that allow you to extend its capabilities. And this is really a really neat piece of it. Allows people to build on Postgres a lot faster. And PGVector is the primary extension for storing and managing those embeddings. And as I mentioned earlier, it's quite mature. So we've got Azure and Docker. You'll be able to run the code and run it on Docker. You could also turn around and give it a connection string and point it to an Azure database like I have right here. I showed you a little screen. You have to enable the vector database by going to settings, server parameters, and then making sure that in the Azure.extensions that you select vector to allow it to be installed. So just a little bit of housekeeping there. So we've got these embeddings, but now what do we do with them? We've captured all this semantic meaning. So we got to talk about similarity search. And basically, a similarity search compares one embedding with another to determine how similar they are. And it really is a math problem. And how that determines similarity can take a few forms. If you think about these on a chart, you can see that cats and croissants are probably not very related, but cats, and I love cats so much, would be related because they are similar. So what we use is mainly something called cosine similarity, which is basically between 1 and 1 and negative 1, 1 being completely synonymous and negative 1 being completely opposite. We're able to determine if the closer it is to 1, the bigger the number, then how similar these two things are conceptually. Cosine distance is another one, and there's other ones. There's dot product. There's I can't think of the names of them off the top of my head, but there are other ways to measure this. Cosine similarity and cosine distance are typically the most common ones. It's the ones that I recommend you start with. And cosine distance is 1 minus cosine similarity. So 0 means that they are more similar. So the smaller the number, the more common they are, the more like each other they are. And closer to 2 means that they are conceptual opposites. So we could talk about this all day, but we got to get to the meat. We got to get to where the rubber meets the road, which is that in order to do a similarity search, we need an embedding model, a series of embeddings, and our vector database. And that's where RAG comes in. RAG is retrieval augmented generation, the act of adding useful information to the context window based on the user's request. We can do it as part of a tool call, as part of a separate call to a different system before handing the request over an LLM. It doesn't require similarity search, but what I'm going to be demoing for you is how we would RAG inside of Agent Framework. And I'm going to show you real fast. I'm going to go here and I'm going to go to my program. And what I'm going to do is the program is a lot of messy stuff to just set up the database, because we are talking about making sure that the database is perfectly set up. I try to make my examples as turnkey as possible. But you're going to notice that when we define our OpenAI client, we're actually getting an embedding client now. In addition to, we will get the chat client further down, but we need the embedding client in order to generate the embedding. And what I've basically created here is I've basically said, down here where I defined my agent, that we have a context provider factory. So this is another piece built into Agent Framework where we get text search provider. And basically this text search provider is a class that is defined inside of Agent Framework. And what we're doing is we're basically passing along our search adapter, which is our function that actually performs the search against our database, okay, using our search service that we've defined up here. and a bunch of other stuff that you need in order to make sure that text search provider can do its job. And what we've got here is really a very exciting array of women's wardrobe stuff. So tops and pants and all the kinds of things. And what would they be appropriate for? Are they appropriate for business casual? Are they appropriate for outings? So we've got a series of queries. And what we're going to do is we're going to run this. Boom. Postgres, let's see, agent search external, use our vector database here. So we'll hit play and you'll see what dresses do you have? So it's going to go through, it's going to do an embedded, it's going to do a similarity search using the similarity search. And I wish I could get into more of it, but no, the things that you're going to be looking up are going to be cosine similarity in PGVector. Very simple. And then it says it's going to do a search against our database. And then it's going to find, we currently offer the women's sleeveless red tank dress by Diesel. And under the hood, if you're looking at this, what's happening is that Agent Framework is doing a call to this and then adding an additional message to the chat completions array to say, here's some additional context that might be helpful for answering your question. So that's all baked into Agent Framework, which is really nice. And then, of course, we can keep going. Do you have any summer tops? And now it's going through and it is doing that similarity search inside of Postgres. And then it says, here's several summer tops in our collection. And you can see here inside of my vector database, I've got my, I got to resize it a little. There we go. And you can see that we have all of our vector database. So we've got the name of our clothing item, the name of our garb, our contents of that, and then the embedding, which the embedding is composed of a combination of the name and the contents. We sent this off to an embedding model. I did all the hard work for you of spending all the money and then just creating the SQL script for you to generate the embeddings. And then all you've got to do is just generate the further embeddings from there to actually do the query. And so what is happening under the hood is this is taking the query that the user has, converting that to an embedding, and then sending a query into Postgres to actually say, what are the most similar things to the user's query that we have stored in our vector database? So fairly straightforward at its surface. There is a little bit of nuance. Whereas this example specifically does a full text and embedding search because most of the searches that you're going to be doing, most of your RAG systems are probably not going to be straight embeddings, period. RAG is not a simple problem to solve. It is actually a fairly complex and nuanced one. It really boils down to your business case, but it's my advice is to know the tools and know what you have available to solve from there. As I mentioned, I use Azure. Obviously, Azure was built a lot of my business, and flexible Postgres server, I think, is as good a Postgres server as available. I like it a lot. Got my pin saying that very honestly. Microsoft ain't paying me to say this. I'm telling you, flexible Postgres server in Azure is good. It's a good service. But the examples that I have inside of the code repo are easier. All you have to have is Docker. Then you don't have to set up a separate service. All you need is Azure OpenAI, or you can convert the solution to use OpenAI. Best practices. Got to mention some best practices. Keep this slide. Keep this slide on handy, okay, when you're building these systems. Use your embedded indexes. HNSW was a paper written out of Microsoft, IV flat. I use HNSW. Understand the pros and the cons of using either of these and make sure that you're doing query analysis. So using the explain keyword to actually say, make sure that your indexes are being used, because otherwise you could be running a query that's super, super slow. You can request smaller vector sizes from OpenAI and other services instead of using the default. That's important because PGVector indexes are limited to 2K vector dimensions, 2000 vector dimensions. So you can't use what comes out of text embedding 3 large natively, but you can say, hey, just give me 2000 embeddings instead. You trade a little bit of efficacy, but you're able to then actually turn around and use the vector, the smaller vector size and then index on it. And then don't sleep on quantization. Quantization is chopping off some of the digits in your float in order to make it into something that's smaller, easier to store, and it would be a little easier to store. Takes up less storage space. So it's reducing the size of your vector. You get a small search performance penalty. I think that the trade-off is absolutely worth it because embeddings are huge and they will get huge. So use the half-vec data type. Those are my kind of best practice questions. Or best practice things in PGVector, some things that you need to know. I'll pause there. Aaron, I know that we're over time, but there's got to be a good question there somewhere.
Oh, yes. Lots and lots of great questions. And thank you so much, Spencer, for really getting into the nitty-gritty for us.
Yes.
I see here, I'm going to kind of go through for our viewers here, but keeps learning Yogesh. I see a question here about how can it handle multiple prompt calls at the same time? There are multiple, I do think, different answers into this, but we did put a link into our Microsoft Learn challenges and our Microsoft Learn content. So it'll have some more of these high-level answers to questions about prompt calls and the multi-agent orchestration for some of those things. Another one is from Vinay's751 about running these programs on Azure free subscription. Completely understand. There is the tokenization of a lot of these things can be really, really high. I would say that we do like a little Microsoft plug. We offer a couple of different, if you are a first-time subscriber to Azure, if you're a student tier, and there's also some for entrepreneurship versions. So if you are really looking to build and maybe test some things in production, we have a couple different other free offer modalities that are available where we have a credit incentive with that as well. So it might be a little bit few and far between, but I would point to maybe checking out some of our different Azure offers, specifically around maybe an increase in tokens to test a lot of these things out. And then
that's probably a good use case for local models if you're not able to get the tokens.
That's also a great point from Spencer. Yeah, leveraging local models that we talked about briefly earlier. Latency, thinking about what is the best use case for some of these different items. That could be a really, really good one if you do want to do locally, because tokens might be kind of that barrier to entry. And then I'm seeing something here from Christopher Rojas, 1731. Yes, we will share the repository if not already. It'll have links to, actually I'll let Spencer kind of give an overview of what that repository will look like. But essentially we'll cover a lot of the different things that Spencer went over today for all the examples that he used as well.
Yeah, for sure. I've got YouTube on my thing. I'm just waiting for the chat to load so that way I can actually drop the repository. But yeah, I definitely recommend running these examples, deconstructing them. I would say the agent framework by far is the easiest part of them. It's really the concepts around it, and RAG in particular is like we could talk 4 hours about RAG and just scratch the surface. But I do want to make sure I give a good amount of time to talking about like how do you deploy and scale AI agents, right? I want to make sure that I at least touch on it. Yep. So the option, there really depends on your use case. How are you triggering them? Lots of times I'm actually not triggering AI agents behind some kind of API call. It might be some other internal service or internal process that's running, that's actually then turning around and running these things, that's triggering these AI agents. And it really basically always depends on the use case. But you do need to worry about authentication and rate limiting, because let's be real, and I've said this already, LLMs are really expensive. They just are. So Azure's AI management is a cloud native way to manage those AI deployments. If you're on Azure, if you're using a myriad of Azure services, it even supports MCP. If you want to define your own MCP server, you can put that in front of API management and then and then basically have a turnkey way of getting that authentication, getting that rate limiting, getting that stuff that logging and monitoring, that load balancing, if you need that. If you're really enterprise scale, right, you really need all of that. You might talk to Azure App Service through API management. You might talk to Kubernetes. You might talk to an Azure function. You might have an MCP server defined, right? So API management is just kind of a layer in between that allows you to do that a little bit easier. So that's my plug. You can see that I spend most of my time talking about Postgres and most of my time talk about agent framework because I found that the most interesting. But hell, this is important too. Heck, I should have said heck. Excuse me. I'm sorry. Apologize. Just a little slip. Okay, I just dropped the link to the GitHub into Slack as well, or sorry, into the chat as well. And then I have time. I mean, I don't know if you need to end, that's fine. But I have time for more questions, or I can go back in the chat. You can always reach out to me. There's the QR code link to the repo. You can always reach out to me with more questions as well. I'm also on X @Schneidenbach. if you can figure out how to spell it. But I don't know, man. Aaron, it's been fun.
You as well. Yeah, no, I see some items in here, but I think, yeah, there's probably, well, I see that we have maybe just a couple more questions.
Yeah, hit me.
We want to go through. From, let me see where we leave off. What message? I think this might be a good one that seems to be a little bit more common, but I see something on here for what are the most commonly used use cases that people are seeing ROI. I think that's kind of like a dual one from you, just given like your background in entrepreneurship. And there's another one around use cases for the company. So yeah, I guess maybe like what are just for you, Spencer, some common use cases that you see and or that you yourself leverage around starting a business and ROI, generating money, in addition to like all like the technical kind of things that we're seeing.
That is a big question. So you wanted to start a business with AI. I mean, I think that bottom line, you can't put the cart before the horse. I mean, now I got my business hat on. You got me on my soapbox. But really, you have to. It all starts in business. It all starts with a good idea. But customers are asking for, how is this AI? How have you integrated AI into your offerings such that we're able to use AI features? And quite frankly, customers don't necessarily know what they want from an AI point of view. They just say, they hear AI, they think this thing needs to be AI enabled. So my best thing to say is really honestly start with the good idea, and AI can just be sprinkled in here and there to solve for specific pain points. Maybe you have somebody, a really nuanced thing, and you need to build a knowledge base around that nuance. And you might create an LLM agent that your internal people use to search that knowledge base, right? Not even use your customers. So it really kind of comes down to the use case. I know somebody asked me about like ballpark price tag to implement one simple agentic model for my company. Boy, that is a question I simply cannot answer. It just really depends on like what the agent is, what it's doing, what guardrails it needs. Like if you ask me to build something that, hey, kids are going to be talking to this, okay, just the guardrails alone are going to be a huge part of the conversation. And it's probably not going to be cheap because that's really important in that case. And I'm going to insist on it or else I'm not going to take the project. So it really, I know, Aaron, it just seems like all these, so many questions. The answer is it depends.
Yes. It unfortunately does depend on a lot. I think some other additional insight I can give is, obviously, or not obviously, but I do work at Microsoft. For any viewers who maybe joined late or didn't realize that, but I work at Microsoft on the AI apps and agents team, and I dabble a little bit in my own entrepreneur stuff as well. So I think for me, I agree with Spencer exactly what he says. It does very much depend on a lot of different factors. I think just to get started, go to Claude, go to ChatGPT, go to your favorite chat interface, and maybe do a deep research, let it think for 20, 40 minutes to an hour on what are the top SEO things that people are looking for? What are the top use cases that we're seeing for maybe that you have a specific idea? I think AI can be leveraged obviously within whatever product or platform that you're building, but also like on the front end of just like helping to get you started thinking around some of these questions that we're seeing here in chat, and being able to shorten the time from a lot of this deep research that needs to be done to maybe feel really comfortable and confident about your idea, so that you can kind of keep the momentum for a lot of some more of these entrepreneurial questions that I'm seeing as well. One other piece I'd like to add from Maxwell Guru, I see that you have a question here about the investment in AI infrastructure. Again, this is on that same kind of line about entrepreneurship. The one thing I'd add here is AI infrastructure is so new. It will continue to evolve. I think that, again, could be a whole separate series that we could talk about for a while, but I would like to point out on the links that we shared for Microsoft Learn around how to use agent framework, there are additional links on there for what we consider like kind of intro to AI infrastructure. Again, it's a big topic. It has a lot of depth. It's ever changing very rapidly, but I think that's probably another good place to start if there are any other individuals who are maybe looking at, when we're talking about platform software and then the HPC GPU acceleration piece around that. We can do another episode, but I point you there first around that. And then last, I think we have one last question from Christopher Rojas, and this is about the PostgreSQL for what other algorithms instead of cosine similarities are available, and which ones should they use for different cases?
That is a good question. Honestly, what you use really comes down to the evals that you're writing, and it really comes down to like cosine similarity is going to be plus hybrid search using something like BM25 or text indexing. That's probably going to be where you look. You're probably not going to get too much into the nuance of like what algorithm should I use, but luckily the PGVector GitHub page has a lot of information on like which ones that are available. So you can see this one's, let's see, L2, negative inner product, cosine distance. Again, I usually do cosine similarity. It's just usually what I've standardized on. Inner product is
You need to zoom in a little bit.
Oh yeah. Inner product is another one. I suggest really honestly, like that is a big question that can only be answered through diligent research. Let me see. I'm just going to drop this PGVector GitHub, and I'm going to put that there. That is going to be like good research is going to really answer that question. The one thing that I would look out for is most embedding models normalize the embeddings. In other words, the direction of the vector matters, but also the intensity, right? But the more intense basically the length of the arrow, the longer the arrow, the more it might override the other relevant results. But a normalized model like open text embedding 3 large and small, those are both normalized, are going to make sure that those those arrows are of equal length for all of their embeddings. So that way you're really only checking similarity. So that would be the only gotcha if you're using smaller and different open source embedding models. That would be the only thing that I would look at because I believe, it's just something to be aware of. Another term really for you to Google. I could go into it more, but like, time again, we can't do all the things.
Awesome. Well, Spencer, if you don't mind just going back to your code slide, just so perfect.
Yes, this is the QR code to the GitHub repo, and it's also in chat.
Yep, awesome. Well, I know we're at time, a little bit over, so thank you to our wonderful production team. Thank you to our viewers who have tuned in live. For anyone who's watching this on demand, please continue to leave questions in the chat. Please continue to leave comments on the video. This will help us get a better idea of what to bring to you next time. Would love to bring Spencer back. And if there's any other questions or use cases that we're seeing a lot of traction on, we definitely want to build something around that. So thank you again for viewing with us. Thank you, Spencer, for coming on today for a chat. And anything else that you want to leave off with us?
Yeah. Evals, test all your AI things, all turnkey, shorten that feedback loop. You got to write evals. If you're going to write AI systems, that's the only thing I'll leave you with.
Well, thank you again. Appreciate it. Until next time. Bye, guys.
Yes. Thank you very much.
Thank you. Thank you all for joining our session, and thank you to our speakers. We are always looking to improve our sessions and your experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat, and we'll see you in the next one.